Hey algebra people, today we're going to be going into a little bit more advanced factoring, and in these factoring exercises we're going to have ax squared plus bx plus c, and the coefficient of the quadratic term is not going to be 1. This time we're going to get positive and negative ones, or positive and negative coefficients. So if we're taking a look at this very first exercise here, we see that 2x squared plus 5x plus 2 has been rearranged already into a rectangle. If I draw bars in between the tiles, I can now just go ahead and draw in the kinds of bars that I would expect to see. So this is one long bar on two long bars across the top, one long bar on the side, and then two small squares on the side and one small square on the top. So factoring wise, this looks like x plus 1 multiplied by x plus 1 plus another 1. And then when you simplify this over here, you're going to get 2x plus 1 multiplied by x plus 2. Now I know that's not always feasible for us to make rectangles out of our algebra tiles. So sometimes we're going to need to have other methods. Here's another one. Let's see what we can do here. Just looking ahead, this looks like it's going to be 1, 2, 3x plus 1, 2 multiplied by, this looks like 1x plus 1. Of course, if these algebra tiles work really well for you, then I highly recommend you keep on visualizing them. Now, once we get over here, the algebra tiles get a little bit messy, so it's a little bit more difficult to do that. But let's try to do this one with algebra tiles. So we've got 4x, and we're just going to rearrange these into into a rectangle, really. And then for the green x bars, let's put 2 of them over there on the side, 2 across the bottom, and then we could take a units and put it there, but I still have this one yellow unit square with no place to put it. So the next thing I could try is moving all of the x's over on the side, and that still doesn't really get me a rectangle. So let's see, did I do something wrong here? Oh, I did. Look, it should be a -3. So I have the wrong tiles here. And I don't mind modeling that for you. Modeling that mistake, that is. Because that's bound to happen sometimes. And you can see that this is going to be a little bit difficult to form our rectangle. But now that we have positive and negative tiles, it is possible to just add in a 0 pair. So if I bring out 2 positive x tiles, I could also bring out 2 negative x tiles, and we can line these up. So that was kind of difficult, actually. And let's get the factors on the side. That's a 2x, and then it's plus 3. Let's put these up here. And on the side, we're going to have an x, another x, and then this time I'm going to need a -1 over on the side. So what does this look like factored? This looks like, on this side, we've got 2x minus 1. And up across the top, it looks like we have an x, 2x plus 3. Now, if those algebra tiles are difficult to come up with, I don't blame you. I had a hard time with that too, you saw. So there has to be another way of doing this. And this is where our good friend, the diamond, comes into play. But we have to do something special for this diamond problem because we've already identified that up over the coefficient of the quadratic term is 2. So if we take a look at the standard form of a quadratic equation, ax squared plus bx plus c. In the red square, we need to do a multiplied by c, and in the bottom square, we need to put the b term. Looking at this particular problem, I can see that the b term is negative 11. So we're going to replace b with negative 11. I also see that a is 2 and c is 5. And then 2 times 5, that's just positive 10. So now we're going to play this like we normally do. We can see that this is a addition problem because that's positive 10. So we're going to add the factors of 10 together. So what are the factors of 10? That's 1 and 10, because 1 times 10 is 10. And when you add 1 and 10 together, you get an 11. So this is what we're looking for. We're looking for 11. Negative 11, but we are looking for 11. So we get a 1, we get a 10. And they both need to be negative in order to add to make a negative 11. Now this is all stuff that we've already done in the previous factoring that we did. So we need to show you how to complete this problem. So to complete this problem, rather than write, we're not finished with the factoring. We're going to start by writing 2x squared. But then the next thing we're going to write is minus 1x. After that, we'll write a minus 10x. And then we'll finish off with a plus 5. After we've done that, we're going to go ahead and we're going to do some grouping. So we're going to group these first two. We'll put a plus sign, and then we'll group the second two. Let's create a little bit more space here. What we want to do now is factor from each of the two groups that we just made. So in this first blue group, I can factor out an x for sure, and then nothing else from 2 and negative 1. So if I factor out that x, I get x, 2x, minus 1. Put the plus sign here. And in this second group, I can't factor out an x, but I can definitely factor out a 5. And more so, because you see a negative 10x, that first term is negative 10, I'm not just going to factor out a 5, I'm going to factor out a negative 5. That's the big rule here. If this first term is negative, you have to factor out a negative. So if I factor out that negative 5, I'm left with a 2x minus 1. Look what happened. We've got a 2x minus 1 and a 2x minus 1. So I'm just going to write that 2x minus 1 and take a look. If I cancel out those 2x minus 1s, what's left over? Well, in that first term, I get a leftover x. And in the second one, I get a plus minus 5, which is basically the same thing as minus 5. So that may not seem at first glance like it was going to be easier, but it actually will save you some time factoring these. So we're going to fast forward and look at some practice, because this does take some practice. Let's do this first one. 2c squared minus 14c minus 36. So the first pair that you need to do is, oh, you know what? I'm looking at this and everything is even. look at this. We've got 2 is even, 14 is even, and 36 is even. So the easiest thing to do here is to factor out a 2. So 2 divided by 2 is 1. 14 divided by 2 is 7. And then 36 divided by 2 is 18. So that makes things a little bit easier for me. We don't need that 1 anymore. And now this turns into a regular factoring problem. So up on the top, we'll put a negative 18. At the bottom, we'll put a negative 7. And we'll need two numbers that multiply or that subtract to make negative 18. So what are the factors of 18? Well, we have 1 and 18, and if we subtract them, we get 17. So this one's wrong. We also have 2 and 9, and if we subtract them, we get 7, which is perfect. So we need to put a 2 and 9 in blue and yellow. Which one of these has to be negative? Which one has to be positive? Well, I think this one here should be negative, and this one should be positive, because we want to make a negative 7. So because this is an easy one, it's easy because now inside the parenthesis, a is 1. We will have c plus 2 and c minus 9. So if you can factor first, that's usually the best way to go here. And I'm taking a look at number 2. In number 2, we can also factor out a 4. So if I factor out a 4, I get a squared plus 2a minus, oh, what is this one? 35, I believe. And then now this becomes an easy problem with the 35 on the top and the 2 on the bottom. So that's not a problem. Let's see this one. Oh, this one I can factor out a 3 from everything. So let's do that slowly. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. Negative 24 divided by 3 is negative 8. So then you can do a diamond problem on this one with a negative 8 on top and a negative 2 on bottom. Let's see if we can go to the next one, number 4. Number 4, it looks like I can factor out a 2. So let's factor out a 2. 2d squared divided by 2 is just d squared. Minus 2d divided by 2 is negative d. And negative 60 divided by 2 is negative 30. So when I set up this diamond problem, negative 30 up top, negative 1 in the white. Let's go over the factors of 30. 1 and 30, and if I subtract 1 and 30, I get 29, so this one isn't correct. I can do 2 and 15, and when I subtract 2 and 15, 15 minus 2 is 13, so this one doesn't work. 3 times 10 is 30, but 10 minus 3 is 7. Again, I need to get a 1, so this one doesn't work. 5 times 6 is 30, and 6 minus 5 is, oh, that's 1. All right, so let's put 5 and 6 here. And if I want to get a negative 1, I should make 5 positive and 6 negative. So the solution here will be 2, d plus 5, and d minus 6. We're going to skip ahead to number 8, and we've got 6k squared minus 11k plus 4. This time I can't divide anything, so I need to go with the more advanced method. So we'll grab a diamond. The red part will get 6 times 4, which is 24. And then the white part of the diamond will get negative 11. So now we got to figure out two numbers that are going to multiply to make 24, and you saw that that was plus, right? So they need to add to make 24. Multiply to make 24, add to make 11. Okay, 1 times 24 adds to make 25, so that's wrong. 2 times 12 multiplies to make 24, but they add to make 14, so this is wrong. 3 times 8 multiplies to make 24, and it adds to make 11, so bingo, 3 and 8 go in blue and yellow. So since I need to make this a negative 11, then both of these have to be negative. Let's double check to make sure we got this right. Negative 3 times negative 8 is equal to positive 24, which is what we have in the red part of the diamond. And then negative 3 plus negative 8 is negative 11, which we have in the white part of the diamond. So we have the correct numbers. So we're going to set this up for the advanced factoring, because remember we have a 6k squared. So the first thing we want to write is 6k squared, which comes from the yellow part. Then we want to write minus 3k, minus 8k, and then finally plus 4. We're going to group things. So our first group is going to be these two factors, or those two terms. And it looks like I can divide both terms by 3, and both terms have a k. This is going to be a pattern. This first grouping, you can pretty much always take out the variable. So you got 3k, and that leaves me with a 2k minus 1. Now the second grouping, I'm going to group and put a plus sign in between. And it looks like I have to do the negative. I want you to look at that. This first term has a negative, so I have to do a minus. And then what number do I need to use? It looks like I can divide these both by 4. So I can divide those both by 4. And if I divide 8 divided by 4, that's going to be a 2. And 4 divided by 4 is a 1. So minus 1. And then now I hopefully you see this. They both have a 2k minus 1. So we'll put a 2k minus 1. And then the thing that's left over here is a 3k minus 4. So that was more of the advanced ones. Hopefully we can get another one. And I think so with number 9. Let's try number 9. Another advanced one. First we'll hook us up with a diamond. Then we'll do 9 times 2 is 18. So we'll get an 18 up there. The middle term is plus 9. So we'll put a plus 9 here. I should have made this plus 18. So plus 18 on the top, plus 9 in the bottom in the white square. And then let's go ahead and figure out they need to add to make 9. Remember that this is an addition problem. So what are the factors of 18? We've got 1 and 18. If we add them, we get 19. That's not good. We've got 2 and 9, and if I add those, I get 11. That's not good either. I've got 3 and 6, and if I add those, I get 9. So that is the correct answer. We've got a 3 and a 6. So we're trying to go a little faster here. We got a 3 and a 6. So we're going to start off by writing 9w squared. 9w squared. And then we'll write plus 3w. And then we'll write plus 6w. And then we'll write plus 2. Okay. Then we'll group. And I'll do this in a separate step. We'll do 9w squared plus 3w. Put a plus sign. And we'll do a plus 6w plus 2. Let's take a look at this first group. I got a 9 and a 3. And it looks like I can divide both of those numbers by 3. And then, like normally, we'll put a w there. 9 divided by 3 is 3. 3 divided by 3 is 1. Over here, 6 and 2. Well, you know that's going to be a 3. No. 6 and 2 are both divisible by 2. This 6w divided by 2, that's 3w. 2 divided by 2, that's 1. We'll get the matching piece out of the way, 3w plus 1. And then the other piece that is not that's now going to be highlighted yellow, that's going to be 3w plus 2. Okay, so getting a little bit faster here. Let's try another one. All right, my number 10 is going to be 12 a squared plus 5a minus 2. We'll get our diamond here. We're going to do 12 times negative 2. That's negative 24. Plus 5 goes in the white square. So we're looking for two numbers that multiply to make 24 and subtract to make a 5. So we'll start with the factors of 24. 1 times 24, but if I subtract, I get 23, so that's no good. 2 times 12 is 24, but if I subtract, I get a 10, so that's not good. 3 times 8 is 24, and when I subtract, I get a 5. That's the two numbers that we want. We want a 3 and an 8. And it looks like if I want to get a positive 5, I'll need a positive 8 and a negative 3. Let's write this down. We've got 12a squared to start off with. And then we'll put a 3a or minus 3a. And then we'll put a plus 8a. And then we'll put a minus 2. Hopefully you got that pattern now. Now we're going to group these together. Okay, let's group these two, put a plus sign, and then group the second two. Let's take a look at the first grouping. I know I can factor an a, but I can also factor out a 3, because 12 divided by 3 is 4a, and then 3 divided by 3 is a 1. In the second grouping, 8 and 2, it looks like I can factor out a plus 2. And I know it's a plus because of the plus sign right there. And what do I get? I get 8 divided by 2 is 4. And then 2 divided by 2 is 1. Then now I'm taking a look at that, and I've got the common factor of 4a minus 1. And then I have the leftover pieces of 3a plus 2. Let's color code this so we can see where all of how that came about. There we go. So that's number 10. I think, yeah, we should probably stop here, and hopefully all of these factorings are going to be useful to you, and I'll see you next time for more algebra. Have a good one, everyone.